0. So AY is equal to omega naught L over 2 minus BY. Okay, so this is my equation number 1. Okay, and then we're going to take moment. Okay, we're going to take moment. So you want it to be a function of BY, yes or no, right? You have to have BY on the right hand side. So you are going to take moment at point A. Okay, so when take moment at point A, so when we're taking moment over here, you have MA, which is positive, right? Then minus, still positive BY, BYL is going anti-clockwise. Okay, and then the load is going, the gradient load, the equivalent load is going in the clockwise. So minus by omega naught L over 2, and then multiply by 2 2L over 3, because the distance from here to here is equal to L over 3. Okay, so moment at point A, so the whole thing is equal to 0. So moment at point A is equal to plus omega naught L squared over 3, right? Then minus BY L. So this is your equation number 2. Okay. So as I said, I'm going to use positive shear and positive bending moment, okay, to solve for our moment equation. So we know we're going to do from A to B, point A to point B, right? So 0 Z to L, okay. So from here, we draw our free body diagram again. So we know this is equal to what? This will be equal to omega naught L over 2 minus by BY. Okay. And we know that moment about point A. So this is moment about point A is equal to omega naught L squared over 3 minus by BY L. Okay. Then we have another load over here. Okay, so that load over there is equal to what? Is equal to omega naught X squared over 2L. Don't make mistake, okay? This is not omega naught L over 2, okay? So this one is our function, okay? Our function over here. Okay, because now we have a variable X. So the distance from here to here is X over 3. Like before, what I told you, sort out your distance first, okay? It's exactly the same. So now this is V as a function of X, M as a function of X. So I don't need, or we don't need the what? The V as a function of X, right? Okay, so we only need the moment part, okay? So the moment part, so we are going to do summation about moment in the Z direction as a function of X is equal to 0. Okay. So our first moment is going anti-clockwise also. So it's our omega naught, right? L squared over 3 minus by BYL. Okay. So this is our first expression over here. Right. It's already a moment. You don't need to multiply by distance. Okay. Then the next one is minus omega naught L over 2 minus by BY. Okay, now this one you have to multiply by X, right? Because it's minus because it's going in a clockwise direction. Okay, then plus, right, your distributed load omega naught X squared over 2L X over 3 plus by moment as a function of X, the whole thing is equal to 0. Okay, so now you just need to rearrange. Okay, so now what we have is M as a function of X, right? So I'm going to use the biggest term first. Okay, so this is minus omega naught. Okay, so this x cubed over 6L, right? Then plus by omega naught L over 2. Okay, so plus by omega naught L over 2x, or omega naught x. So then minus by byx. Okay, minus by byx. Then the whole thing, this term I just bring over, minus omega naught L squared over 3. Okay, and then plus by byl. Okay, plus by, let me check, am I right? This is a good time to make mistake, minus byx plus by. Then this whole term will be equal to ei d squared y over dx squared. So this, at this point, this is where we apply elastic curve. Okay, so this will be, what equation are we now on? Blah 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 2. This is our equation 3. And this will be our equation 3a. So now it's just, we are done with the diagrams. Can you see that? We are done with the diagrams. Now it is just matter of what? Integration, which you all are much better than me. I'll tell you that. Okay. What you guys learn for integration is so much more, which is important for some other subjects, like those in energy stream. Those equations are, those complex integration are important for you guys, for them. Okay, for us, sometimes maybe we use it for controls. Okay, I'm going to copy and paste this across. Yeah, not a very good thing to do. Okay, so from here on, it's all math. Okay, there's no physics anymore. So physics has been turned off. Okay, math has been turned on. Okay, I hope you guys get my. Okay, so from here, I'm just going to do it. Okay, if I make mistake, help me find any mistake. Okay, so this will be ei dy by dx is equal to ei theta. So this is equal to minus omega naught x4 over 24L plus by omega naught L x squared over 4 minus by by x squared over 2 minus by omega naught L squared over 3x plus by byl x. Okay, and then plus by, I think this is our first constant. Okay, so now with this first constant, can we do anything? So let me check. Blub 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 blub. Yes. So can we apply any boundary condition? Yes, we can. Okay, we can apply this one. And thank God it is 0. Imagine if x is equal to L. Now you say, oh, not again. Yes or no? Right? Sorry. Very dry humor. Sorry. So we're going to substitute where x is equal to 0, theta is equal to 0 into equation number 4. Right, so as you know, so one side is 0 is equal to minus 0 plus 0 minus 0 minus 0 plus 0 plus by C1. And this is good news. Therefore, C1 is equal to 0. Okay, so we now know that we have EI theta, or dy by dx, is equal to minus omega naught x4 over 24L plus by omega naught L x squared over 4 minus by byx squared over 2 minus by omega naught L squared x over 3. That's why when doing the term test or exam, you're done with term test. The exam for this course, you need a lot of sleep. Okay, and you cannot get high. Okay, if you are high, you are done. Then we integrate the last time. Okay, so this EIY minus by omega naught x5, okay, 120L plus by omega naught L x cubed over 12 minus by by x cubed over 6 minus by omega naught L x squared x squared over 6 plus by by L x squared over 2 plus by C2. So this is equation number 5. Okay. So I'll check blob, yes, x cubed, Lx cubed, yes, Byx cubed, yes, minus omega naught L squared x squared over 6, yes, plus by By Lx plus C2, yes. Okay, so next we look for any good boundary condition. Oh, another beautiful one. Okay, so use this one. Okay, don't be a snob and use y equal to 0 and x equal to L. Okay, you're gonna it's gonna be so long. Yes or no? Okay, don't be a snob. Oh, here you go again. Okay. Don't be like me when I was young. Yeah. Work hard but not work smart. Okay, that is a no good approach. Okay. So we're going to substitute when x 0, okay, distance 0, deflection is equal to 0 into equation number 5. Okay, we're going to substitute this into equation number 5. So what you see again, good news. So you got 0 minus 0 plus 0 minus 0 minus 0 plus 0 plus by C2. Okay, so therefore C2 is equal to 0. So the final form of our equation, right, is equal to EIY as a function of x. Now this is equal to minus omega naught x5 over 120L plus by omega naught Lx cubed over 12. Some of you will be asking, where is this going? Yes or no? I also don't know sometimes. When I solve problem like this, sometimes I'm lost, okay? By Lx squared over 2. Okay, By Lx squared over 2. Okay, so this is our equation 5. Can anyone tell me what we are trying to find? I'm lost already, man. It's a long day, man. Can anyone tell me what we are trying to find?
Reaction at B?
Yeah. Right? So we want to find By. Okay. So we have one more boundary condition. Right? So the next one, we're going to substitute. Okay. Why we have to substitute? If this term over here is equal to 0, then we can find, right? Then we can find By. Am I right? Right? Then we can find By. So it is important. I'm almost done. Okay. Don't worry. I won't jump over today. So we're going to substitute when x is equal to or x is equal to L, y will be equal to what? 0 into equation 5a. Right? So when that's the case, this will be equal to 0. This will be equal to minus omega naught or omega naught L4 over 120 plus by omega naught L4 over 12 minus by By L cubed over 6 minus by omega naught L4 over 6 plus by By L cubed over 2. Okay, so this is 0, and then this will be equal to minus 1 over 120 plus by 1 over 12 minus by 1 over 6. So this is equal to minus 11 over 120, right? Omega naught L4, right? And then the next one is minus, no, can be plus, right? Minus by 1/6 plus by half. Okay, so it's equal to positive by L cube. Okay, by L cube over 3, right? So finally, by is equal to, you bring it over, is 11 omega naught L4 over 120, right? Multiply by 3 over L cube, right? So therefore, by is equal to 11 over 40 omega naught L. Done. Right? So this method, and this is positive, and positive is correct. Okay, so how to check whether you are wrong, right or wrong? Not you're wrong, sorry. Okay, if it's positive, means it's what? Going up. The direction means something. Okay, so if you look at our problem, right, by is indeed what? If you look over here, by is indeed going upwards. Okay, so it's going upwards. So let me tell you what's the commonality. Okay, when we were doing, can you remember when we were doing axial loading, right? When it's statically indeterminate, what did we do? Right? We use displacement, right? We use elastic deformation, yes or no? We let it stretch and then we push it back. So we apply deformation. Likewise, for this case, right? When it's statically indeterminate, we need more equation. So again, what did we use? We use deflection. We allowed it to bend, right? Then we find the reaction. Okay, we find the reaction. So over here, we also apply what? Deflection equations. Okay, in axial loading, we also apply what? Deflection. Yes or no? Right? So now, before I end, I'm going to load another like 1 hours of lecture videos, okay, which you can ×2 or ×5 the speed, making me sound like Mickey Mouse. I'm going to do a structure like what was mentioned earlier, okay? If you have a load doing this, okay? So if we see over here, right? Now the thing is this, okay? You have what? You don't have a continuous load. At point A, you have reaction. At point D, you have reaction or point load. And then B to C have an evenly distributed load, okay? I want you to review how I form the equation, okay? It's again a lot of math like this, okay? But I let you watch on your own, okay? And I already posted the solution already. Sorry, the homework already, okay? But I've not posted the solution. Give me another 2 days, then I post the solution of the homework because I have a report to write that it is going to be due on Monday. And it's a working weekend for me. On that note, I'll still be around again for next 5 minutes. That's the end of lecture. Thank you.
Professor?
Yes.
For this positive movement, positive shear, we need to know the distance of the equivalent force acting, right?
Oh yeah, definitely. If you don't know that,
So
game over.